All right, you guys, I'm going to be talking about 8.4c, which is another method that we would use to actually get to our slope. There's going to be a two-parter of this video of 8.4c. The first of which is going to be where we look at rates of change to determine slope, and then the other is going to be where we calculate slope for more of a graphic representation. But this one we did in class also, and we just call this a change in y over a change in x. So let me go ahead and show you what the book looks like. So as you see, the book shows you that rate of change in slope can be interchangeable. It's just another form or way of looking at it. So if we notice here, investigating rates of change, a rate of change is going to be a ratio of the amount of change in the output, also known as your y value, to the amount of change in your input, which is also going to be known as your x value. So as we talked about in class, you're going to identify the input and output variables, which they have already labeled in this particular chart. There may be a time that you actually go from a verbal description and you'd have to construct your own. So you have to remember that your output, again, is y, your input is x. Now, in this particular version of finding the slope, we're going to look at the rates of change as to whether or not they are constant or variable. Constant meaning there is a k value that is consistent in your values, and then variable, of course, where your k value is not consistent. So if we notice here, we are looking at from day 1 to day 2. So I'm analyzing from day 1 to day 2 using these y values, using these x values as my change in y over x. So again, from day 1 to day 2, day 2 to day 3, day 3 to day 4. Now, as you see in this particular example, they are consistent. So therefore, the rate of change will be constant at $15 per lawn that this particular person used. And so we can verify that, again, that line is going to be a proportional relationship because all of the k values are the same. Okay, and we're looking at the change in y over x, and our change in y over x is 15. So that would be our rate of change, aka the slope. So let's go ahead and go on to some examples that we have here in the book, and we'll take a look at those. So for the purposes of these examples, we're going to be looking to see whether or not the rates of change are constant or variable. If they are constant, that's going to give us our quote-unquote slope using the rate of change, and if it is not constant, if it is variable, that would not be a slope, and there is not a relationship where we could actually find a specific slope from the set of data that we are given. So let us go ahead and take a look at these. Okay, so what I'm going to do at this point is I'm going to pull my visualizer over. So I do apologize, you guys, if the video is a little choppy. I just want to get rid of some of the technical issues. So again, we're going to look at example number 1 and example number 2 from what we were doing. So what I'm going to do, what I like to do is I like to just go ahead and label my my different sets of data, okay? Because in this particular case, I'm going to be comparing set 1 to 2, set 2 to 3, and set 3 to 4. I'm going to go ahead and zoom in just a bit. Okay, great. Okay, so as I said, I'm going to compare 1 to 2. I'm going to compare 2 to 3. And I want to compare 3 to 4. This, again, is analyzing our rates of change. Okay, so as we analyze our rates of change, I'm going to be using these y values to this one when I'm analyzing 1 to 2. 2 to 3, I'm going to be analyzing these y values and these x values. And then 3 to 4, these y values and, again, these x values. I hope that makes sense. We're going to use our change in y over change in x, which in essence is the slope formula. And I'll show you how that happens right now. So I'm going to take my second y value minus my first y value over 12 minus 3, second minus first. I'm going to just set all these up so you can see. 9 minus 4 over 27 minus 12. 9 minus 4, 27 minus 12. I'm going to do the exact same thing for 3 and 4. 25 minus 9 over, again, 25 minus 9, 75 over 27. And what I'm going to do is I'm going to continue to simplify. As I simplify, I see that this is 3 over 9. 4 minus 1, 3. 12 minus 3, 9. Okay, so that's what I'm doing. 5 over 15. And let's see, 16 over 48. Now, I believe that these values are constant. Like, wait a second, Mr. Moore, those are not the same. And then I would ask you, aren't they? Because when I simplify them, they all simplify to 1/3 because they all have common factors. This one, greatest common factor is 3. Greatest common factor here is 5. Greatest common factor here is 16. They all simplify to 1/3. So because of the fact that they're all simplifying to 1/3, that means that it's constant. This is my slope. Okay? Just that simple. Now, again, you might ask yourself, why do we do all of these different methods? We do all of these different methods because the student is able to choose the one that actually makes more sense to them. You are the student. You take the power over your learning. Voice and choice is what we call it in the educational field. Okay, so at this point, I'm going to do the exact same thing for this one. This one becomes 12 minus 6. Again, I'm 1 to 2, 2 to 3, and 3 to 4. Okay, sorry, this is jumping around a bit. This camera at my house, for some reason, it likes to focus a lot, so I, again, apologize for this. All right, 12 minus 6 over, I want to pull this over just a bit for you, and I'm going to actually zoom this back out just a little bit. Okay, so 12 minus 6, 4 minus 2, 6 over 2. The next is going to be 25 minus 12 over 9 minus 4. That's going to be 13 over 5. And you guys, if you notice, I made a little bit of a correction. When I was copying them, I did not copy these properly, so I transposed these. So again, this is just another example, you know, me being your example where you need to make sure that everything is copied properly. I didn't notice it, so I looked at my notes. But what I've done is I did go ahead and subtract everything for you. We have 20 minus 25, which is negative 5. We then have 60 minus 9, which is going to give us 51. Okay? So at this point, we have 3 different variations. Okay? We have 13 over 5. I'm going to leave it as an improper fraction. And then negative 5 over 51. Now, at this point, do we have consistency amongst these values? We do not. So this is going to be a variable relationship, not a constant relationship like before. So being that this is a variable relationship, there is no direct variation. There is no constant of variation, also known as K. So this is not going to be an example of a slope that you could actually locate. So this is pretty much the end of this video. This is just one format. Remember, we're going to do a second part which looks at a graph in just a moment. So, as always, if you have any questions, please come to class with those questions. If you would like to show up to tutorials, please do that by all means. And as always, I will see you tomorrow.